Hello guys, and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today with a problem related to friction, forces, Newton's second law, and all those good things. So around the realm of dynamics, the problem statement reads, baggage on the floor of the baggage car of a high-speed train is not prevented from moving other than by friction. Determine the smallest allowable value of the coefficient of static friction between the trunk and the floor of the car if the trunk is not to slide when the train decreases its speed at a constant rate from 200 km per hour to 900 km per hour in a time interval of 12 seconds. So, very simple situation here. Just drove, the baggage and the floor. That's all we have going. And the whole idea is that we don't want this baggage to move anywhere, right? Anywhere. And what is acting on the bag when the thing is stationary, when it's, when the train is not moving whatsoever? Well, we only have or if it's moving at a constant speed, right? We have two forces. We have the weight of the luggage or the baggage, and then the normal force countering that weight and keeping it still in place. Right? Now, if we look at the problem analysis here, there's a couple of things that are important, right? So, no, the only thing that's stopping it from moving is, nothing is not preventing from moving other than friction. So the only thing preventing it from moving is friction. So therefore, there's no kind of wall here, or any type of, other luggage around it, creating other forces. It's just friction. That's the only thing that's stopping it from moving. The other thing to note is that this word is super important, right? The constant change of decrease from one speed to the other. Mm-hmm. What does that mean? It means that the acceleration is a single value, right? And what is acceleration? Well, acceleration is, on its most pure form, how the velocity varies with time, right? Just like that. And therefore, if acceleration is constant, then I can see that acceleration times the variation of time has to be equal to the variation of velocity. And if I integrate both sides of the equation here, what do I get? Well, on this side here, acceleration is a constant, so it can come out of the integral without really changing anything. And I'm going to end up with something like this, acceleration, and I'm integrating all the way from 0 to 12 seconds on the time component. And on the right-hand side of the equation, I'm going all the way from the 200 kilometers per hour down to the 90 kilometers per hour, right? Down to the 90 kilometers per hour. And this is as simple as can be for an integration. And then what we get here is that acceleration, 12 times acceleration will be equal to the difference in velocity of 90 minus 200, right? So with that, what I can do with that information is I can calculate my acceleration, right? Because it's literally going to be the negative 110 divided by 12. I just need to ensure that the units here make sense, right? Because here I have 110, that is kilometers per hour, same unit of, let's change colors, same unit as the velocities we have up there for 90 and the 200. And then at the bottom there I have seconds, right? So these obviously don't talk. They're units that don't allow me to do anything with them. Let's just do it like this to make it clear, like that. Okay. So what I need to do here is some unit conversion. So for that, I'm going to convert my seconds, I'm going to convert everything into meters per second. So that allows me to have everything in meters per second squared. To do that, what I need to do is multiply once, remembering that 1 hour is the same exact thing as 3,600 seconds. And I need to multiply my kilometers out of the way by remembering that 1 kilometer is exactly the same thing as 8,000 meters. Right? And if I do that, what happens is that the kilometers and the kilometers go away, and the hour go away. And then I'm left with seconds squared and meters on the top. So meters per second squared, right? So if I take this into consideration, I'm going to get that my acceleration is approximately negative 2.546, and that is meters per second squared. Okay, So now, if that's the case, meters per second squared, then how do I calculate the friction that is required, the coefficient of friction? Well, the accelerator is related to the force by the relationship that Newton gave us, which is force equals mass times acceleration, or acceleration times mass in this case here, right? And for it not to move, what we want is that the sum of forces on the x direction equals 0, right? So in other words, we don't want any forces going on this direction here. So what we want to do now is, get that back. What I want to do now is think about what is going on once the train starts to brake, right? Brake and it starts to brake. So when it starts to brake, the luggage, supposing it's moving this way, the luggage will want to keep moving wherever direction it was moving, right? So there will be a force wanting to move it to one direction. And what's stopping that movement is the friction force. So we have friction here, F for friction on one side, just a general force on the other one that's caused by the change in velocity, which means there's an acceleration, which means there's a force, right? So for this luggage here not to move, these two forces need to be balanced, and they need to sum up 0, right? So what that means is I want force. So if this is the case here, if I want them to sum up to 0, I mean that I want the F to be equal to the friction force. What is the F? Well, the F is related, once again, to the idea of Newton's second law. So I can transform the right hand. Let me do this like this. So let me go ahead and continue this idea here, over here, right? So force needs to be equal to friction. And this is something that I am saying, right? If I want it to be still, I want them to be the same. And then this component here, I'm going to decompose into this idea here, right? Just Newton's second law, acceleration times the mass. And on the right-hand side, I'm going to decompose the friction into the definition of friction, which is the normal force, right? Normal force times a given coefficient, right? And if you look at this is super interesting, because all these things are things that we have an idea about, right? We know, for instance, that because the luggage is not going up or down, the sum, and now I'm not wanting this, I know this because it's not going up and down, this is the case, and because we only have weight and normal forces acting, then I know that weight equals the normal force. And if the weight equals normal force, that means the normal force equals a mass times gravity, right? So I can go where I have normal force and substitute that by mass times gravity. So therefore I got acceleration times the mass equals mass times gravity times the coefficient of friction. And the coefficient of friction is precisely what I'm looking for, right? Precisely what I'm looking for. So therefore, because I have mass on both sides of the equation, the mass is the same as the mass of the luggage, right? The mass of the luggage, they cancel each other out. And because I have two accelerations now, what I end up finding is that the coefficient that I'm looking for will just be the acceleration that is that the luggage is feeling divided by the acceleration of gravity. And guess what? We know both values, right? Because this one here happens to be 2 point something that we just found out, and this one happens to be 9 point something. So therefore, the coefficient of friction is just going to be a ratio between the two. Okay, and I don't, we can do modular here to get rid of the negative if we want, or we can, say that gravity's upwards is positive and gravity is downwards, therefore it's negative. It doesn't really matter because we know that the coefficient has to be a positive number. So therefore, all I need to do is, the 2.546 divided by the 9.81 or whatever precision you want to get here. And we're going to get, I got 0.25956. It keeps going, so let's go ahead and approximate that to 0.26. Okay, 0.26. And for units, right, there's no units, but we can always be sure what we're doing here is have meters per second squared for this guy here. And we're dividing by the acceleration of gravity, which is also meters per second squared. So obviously, these guys cancel each other. There's no units. We're left with coefficient, which is dimensionless. That's pretty much it. That's the answer for this problem, right? Now, a couple of things that are interesting here. First off, this is the minimum, right? This is the minimum coefficient that is required. Any higher coefficient will also keep it from moving. Why? Because think about it. if the friction is defined as the normal times the coefficient, the greater the coefficient, the greater the friction force, right? And the greater the friction force, the greater this guy can withstand any force opposing it, right? So a greater coefficient tends only to benefit the friction force. And because we know the friction force cannot ever be greater than the force causing it, right? We can have as high coefficient as we want to, and it's going to help us out here to keep it from moving. What else is interesting? The other thing that's interesting is because of this step here in which we notice that there's the mass is acting on both kind of forces, right? The force that's trying to move it and the force that's trying to balance it, the mass doesn't matter. And that's, to me, that's something that's super interesting from Newton's second law, and, all this idea that this understanding of Newtonian mechanics bring to us, right? It doesn't matter whether this luggage is super light, call it super heavy, or anywhere in the middle. It doesn't matter. The mass does not matter. What matters here is the coefficient of friction, and obviously the acceleration that is being that the luggage is suffering due to the deceleration of the train. So I find that super interesting. I hope you guys agree with me. If you have any questions, as per usual, just leave them down below in the comment section. I hope this video helped you out. If it did, consider giving it a like, and we'll talk soon.